We have a couple different algebraic methods to solve a system of equations, but the method that I want to focus on right now is actually the graphing method. Uh, the good thing about this method is it makes you think of what this equation represents. And this equation is just a line. This equation is also a line. So the graphing method, really what it's going to do is, regardless of how you decide to graph the line, you're going to graph two lines. These aren't the same. And just look for the intersection point. And so it's another interpretation of what is the answer to a system of equations. Graphically, it's just the intersection of the 2 points. You have a couple different ways you can do this. You could either graph by hand, as happens sometimes in test situations, but most often you're going to graph using technology, and this is where it's really popular. It makes it a lot easier. So if we look at graphing using something like Desmos, I can type in my equations. The advantage to using Desmos is, you notice I can just type in the equation exactly as written, and it's going to graph the line for me. If I were to do this with my graphing calculator, I'd actually have to solve for y. I wouldn't be able just to enter it in right away. So I'd have to take something like 3x minus 5y equals negative 28, and I need to solve for y. I need to get y by itself. So negative 5y, and dividing both sides by negative 5 gives me, negatives cancel out, gives me a positive plus 28 fifths. And this is what I'd have to enter into my graphing calculator. But if we see Desmos, it just graphs it right away, so it makes it easier. And if I put in my second line, notice that Desmos also color codes it for me, so I can see exactly where it is. And then if I want to focus on, where's the intersection of those two lines, I can just see, and Desmos highlights. It highlights the intersections for me and the intercepts, both x and y intercept. So I have an answer of negative 1, 5. I can go back over here just to show that that answer does in fact work. And I could pick either equation. Let's pick the first one. And let's just substitute in negative 1, comma 5, and see if we do in fact get an answer of negative 28. Negative 3 minus 25. Yep, that's negative 28. And if I want to be ultra sure, I can check the second one as well. So 4 times negative 1 plus 5 times 5, which gives me negative 4 plus 25, or just 21. So it works in both. I can be assured that that point is on both lines and that I have found the answer. Now the cool thing, and one of the main reasons why we teach the graphing method, is not because it's the most efficient, because actually I think elimination would have been better in this situation. But if we consider another situation where instead of having two lines, maybe you have a parabola and a line. Well, the same concept still holds. The intersection is the solution. And if I wanted to look to see where that was, I could do that easily using technology. So imagine if this first equation had just been a common parabola. Now I can see I have two solutions, and this will tell me exactly where it is. Desmos will tell me exactly where it is. Your calculator would also tell you where it is. The cool thing about technology is it can help us out with functions that we don't even know how to solve algebraically. This one that I've given you, you could solve this algebraically, but if I added a sine x in here, now it's kind of weird and we're not sure where it is, but Desmos once again gives us the answer really quickly. So the graphing method has a lot of advantages with more complex functions. It also has the advantage that it gives us an idea of what we're doing. We're trying to find where these lines or where these parabolas or whatever it happens to be, if I added a sine x in there, whatever the function happens to be, where are they intersecting? Graphing method's a really good way to visualize that and to find it quickly using technology.